Yes, today we will discuss about dimensionality reduction. What is dimensionality? Dimensionality is nothing but the number of inputs or features for a data set. Then what is this dimensionality reduction? It is a technique that minimizes the number of input variables or the number of independent variables in a data set. Generally, if there are more number of input features or inputs, the model will fail to make accurate predictions or efficient prediction. So it makes a predictive modeling task very challenging. So large number of input features, if there are large number of input features present in the data set, obviously it is going to cause poor performance for machine learning algorithms. This dimensionality reduction technique is basically used to reduce the number of input features. And performance of the machine learning algorithms degrades if the data set has too many input variables or input features. See, I think by this time all of you are familiarized with the data set, how the data set looks like, right? I think you have been using CSV file, XLS file. If XLS file is there, you know how to convert XLS to CSV in pandas, right? Importing pandas, importing data frames, using data frames, right? So what you have worked so far is the structured data, right? So what you have seen in the data set, how the data is represented. The data is represented in rows and columns. You have seen how the data is represented in spreadsheet, how the data is represented in CSV, how the data is represented in JSON file, right? So here the input variables are nothing but the column values that appear in the data set. So these column values, which represent input variables, are fed to the input model in order to predict the target variable. And these input variables are called features. Okay. The column values or the features represent dimensions as an n-dimensional feature space. Okay, what are the column values? Column values are nothing but the variables. For example, if I say year, a column contains year. So year, it can have different values, right? The column values represent dimensions as an n-dimensional feature space. And the rows of data, what do they represent? Observations, or the rows of data are represented as points in that space. So this is the geometrical representation of a data set. Now, what happens if a data set is large? If a data set is large, it means it has a large number of dimensions in the feature space. Okay, if a data set is large, it means it has a large number of dimensions in the feature space. In other words, we say volume of that space is very large. So if volume of that space is very large, it can obviously impact the performance of the algorithm. So this is called curse of dimensionality. So it is advisable to minimize, here we have to focus to minimize or to reduce the number of input features or the columns or the input variables, which in turn reduces the dimensionality of the which in turn reduces the dimensions of the feature space. Hence the name is dimensionality reduction. In other words, When I say a particular data set has hundreds of feature vectors or feature inputs, or if a data set has 100 input variables, instead of taking all those variables, I can minimize, I can reduce the size, I can take only 50 variables, I can filter only 50 variables. So that is called dimensionality reduction. That is, we are minimizing the larger data set to a minimal data by reducing the number of features, by reducing the number of input variables. That is called dimensionality reduction. So high dimensionality, what do you say? What do you mean by high dimensionality? High dimensionality means in a particular data set, there can be hundreds or thousands or even millions of input variables. For example, Facebook dataset or Twitter dataset, or you say what is that, Instagram dataset. I think all of you have Instagram. I don't have either. Here, these Facebook, Amazon, Twitter, Instagram, they are generating huge amount of data set. Their data set is very large. So they have high dimensional data sets. If we have fewer input dimensions or fewer parameters, a single structure in the particular ML algorithm or in the machine learning algorithm, that model is that is called a degree of freedom. It means when we have less number of dimensions, the model will accurately predict the result. The model will perform efficient, it will give efficient results, or it will perform well on the target variable. So what is this dimensionality reduction? Dimensionality reduction is a data preparation technique. Please remember, it is a data preparation technique which should be performed on data prior to modeling. Okay, before applying any algorithm, you have to perform this dimensionality reduction technique first, and it is performed after data cleaning and before training a predictive model. And what this dimensionality reduction gives? It gives us more compact representation of data, and even it yields more easily interpretable representation of the outcome or the target or the target variable, focusing on the most relevant variables. In the sense, here instead of taking all 100 variables, we consider the most frequently used variables or the variables which are showing high variance. So we are going to filter out those parameters, and we are taking those parameters and inputting those values to the model so that model can perform well, model can predict efficiently. Okay. So let us come down to your real-time examples. In our day-to-day life, we are generating tremendous amount of data every day, isn't it? Let us take example of Facebook, Amazon, Twitter, Instagram, or your smartphone. Facebook, all of you have Facebook account, right? Facebook, it collects your data, what you like, what you post, the places you visit, the restaurants you like, etc. Whatever you do on Facebook, Facebook server is going to fetch your data, fetch your activity. Similarly, Twitter also. Amazon, while you have your Amazon account, while doing your Amazon shopping, Amazon server collects your data, your search patterns, your price range, the color, the color which you prefer, right? What you buy, what you click, etc. On the server collects all these data. And similarly, your smartphone, you have a lot of apps in your smartphone. All those apps collect the data, whatever you do on your smartphone. So you are generating huge amount of data. Huge amount of data is being gathered over the network. as data generation and collection is increasing, visualizing that huge amount of data becomes really challenging task, isn't it? Visualizing that huge amount of data set, coming to conclusion is becoming more and more challenging. And how do you visualize the data generally? Generally, you visualize the data through charts, right? So here, let us take, if we have only two variables, let us take a simple data set where we have only two variables. Okay, here on the x-axis age and y-axis height. Since there are only two variables, we can use a line plot or scatter plot to understand the relationship between the two variables. If we take 100 variables, okay, if we take 100 variables, the number of graphs would be n into n minus 1 by 2. Around you, approximately you get 4950 graphs, right? So for these 100 variables, you will get approximately 5000 graphs. Is it possible to view all the graphs? Is it possible to visualize all the graphs and drawing conclusion? Right? It is very tough and it doesn't make any sense to visualize all 5000 graphs for these 100 variables, right? So here in such cases, where we have a large number of variables, we can select a subset of these variables, that is far less than 100. We can take a subset of these variables which capture, okay, which capture as much as information as the original variables. It means we are not trying to harm the meaning of the original data set. The meaning of the original data set should be retained by capturing only the meaningful columns. So instead of taking 100 variables, I can take 50 variables, then reduce it to 25, then half. Okay. Later on, I can minimize the number of columns as much as possible to visualize the data in an easy method. Okay, now here what is happening in the first case, here you have pound, it is taking 200 values, and x also is taking 85 values. And what are these variables? Let us say, what are these variables? Here we have weights of similar objects. Okay, here weights of similar objects. Along x-axis we have x is represented in kg, and along y-axis x2 is represented in pounds, right? And look at these two variables, both are carrying the same information, right? If we use both of these variables, they are carrying the same information, they are going to convey the same information. So it doesn't make any sense to use these variables. Instead, here both are saying the same information. So instead of using these two variables as input variables, I can take any one input variable for training the model. So what I do here, instead of this, instead of taking these two values, I can take only one value. That is, data is represented here, data is represented in 2D. I can reduce this to 1D. So from instead of this x1 and x2, I can take only either x1 x-axis values or y-axis values. Here data is moved from 2D to 1D. So this is called dimensionality reduction. Any doubts so far?
No.
Thank you. In general, n dimensions are reduced to n minus 1, n minus 2, n minus n. Finally, we bring it down to 2D, 3D or 2D. That is called dimensionality reduction. Next, why is dimensionality reduction important? Why do we use while training our ML models. Why dimensionality reduction is so popular for machine learning algorithms? There are 5 advantages. First one is reduce space. Obviously, if huge data set of huge dimension is brought down to lesser one, definitely the space required to store the data is reduced, because we have the number of dimensions coming down, the number of dimensions or the number of columns we are bringing down, right? So obviously the space will be very less. Second one, less computation time or less training time. Here, since there are fewer dimensions or fewer column values, obviously the computation time will be less. Next, some algorithms do not perform well on larger data sets. They perform poor on larger data sets. So it is better to reduce the dimension. So here, for example, random forest algorithm. I take a huge data set and I input that to random forest algorithm. First, what it does, it captures only the meaningful columns and automatically it selects the features and creates the subset and then feeds it to the algorithm. That is the technique. So some algorithms perform better, some algorithms do not perform better on larger data set. So reducing these dimension needs to happen for the algorithm to be useful, for the algorithm to be to make better results. So, and here there is one more important feature. Dimensionality reduction takes care of multi-collinearity by removing redundant features. It means this removes the unwanted columns. For example, let us say take 2 variables. We have 2 variables. On x-axis, we have time spent on treadmill in minutes, and on y-axis we have calories burned. So here, time spent on treadmill and calories burnt, both variables are highly correlated, isn't it? Here the more time you spend running on a treadmill, the more calories you will burn, isn't it? So these two variables are highly correlated. They are highly dependent on each other. So it doesn't make any sense to store both the variables, because only one of them will serve the purpose. So in the here, this is how the highly correlated features, if any column values are exhibiting any highly correlated feature, we take only one of them. So either I can take treadmill, time spent on treadmill, or I can take calories burned, right? So it takes care of multi-collinearity by removing redundant feature, unwanted data. Next is better data visualization. Obviously, we are reducing the number of dimensions, we are reducing the number of columns, we can have better visualization on the data set. And dimensionality reduction can be done in 2 different ways. First one, by keeping the most relevant variables from the original data. That is, the first method is called feature selection. We are selecting the most relevant features or variables from the original data set. Second one, by finding a smaller subset of new variables. We find a smaller subset where each subset will be a combination of input features containing basically the same information as the original data values. Here, if there are 100 variables, we are taking 50 variables considering the most relevant column values. We are not harming the meaning of the original data set. So there are various dimensionality reduction techniques. How we are reducing the number of columns, how we are reducing the dimension, how we are converting the larger data set into a smaller data set. There are 12 techniques: missing value ratio, low variance filter, high correlation filter, random forest, backward feature elimination, forward feature selection, factor analysis, principal component analysis, independent component analysis, methods based on projections. This is used for image. Okay, the 10th one is used for image processing. 11th one, T distributed stochastic neighbor embedding, TSNE, and next last one is UMAP. For your syllabus, we are covering missing value ratio, high variance filter, high correlation, and principal component analysis. Here I am not covering random forest because when you study classification algorithm further in your syllabus, you will get confused. So that is why I don't want to cover it now. I don't want you to get confused. So I am covering only these four highlighted in red. Okay, next is missing values. What can you make out from this diagram?
It is very high because when we are talking to electronic media, electronic media will also have its own delay. So by the time you are able to get your first word, you are already on.
Yes, try to understand the data. What is happening here?
A lot of missing data, null values.
Yes, this is a particular data set, and here there are how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 columns. It means 11 independent features or input features for this particular data set. And here the age column and cabin column have some missing data. Now here only one value is missing in this particular column, and here 3 values are missing in this particular column, right? Here if data are missing, now the question is, if a data set has missing values, then how can we reduce the time? How can we reduce the number of columns? Here whether to take over this column or this column, right? We come across with so many challenges. So now here missing value ratio. This is a technique where the data set can have missing values for a number of reasons, such as observations not recorded or corrupted or corruption, what you can say. Suppose you are given a data set. What is your natural, now assume that I have given you a data set. What is your first step? You will try to explore that data set first, isn't it? Before building a model, you try to understand data. You try to understand the nature of the data. You try to explore the data. While exploring the data, you find that some values are missing. Certain values, certain columns are missing. So now what we do? Here, if values are missing, we'll try to find out the reason for these missing values, and then if there are some missing values, we will impute them, right? We will impute those values or drop the values or drop the particular column. For example, here if there are missing values, we go for imputation. Imputation in the sense we replace the value, replace this empty column with some value. And here how many observations? There are 6 observations. Only 2 values are present in this. So in this case, lot of missing values are there. So what we do, instead of filling the most relevant value here, frequent value here, what do we do? Either we can drop this column or we can fill up the value with some relevant data. Okay, so here what happens if we have too many missing values? Say for example, we'll see the next data. This is one more data set. If we have too many missing values, say more than 50%, okay, if missing values is more than 50%, see here like the first one, here missing values is less than 50%, you can say, right? Number of observations are more, but missing values is 2. Here missing values is only 1. Here 2 values are missing. Here 1 value is missing. 2 value are missing. And here in this column, pets column, lot of values are missing. So what do? Here we calculate the missing value percentage. If the missing value percentage is greater than 50%, if missing value percentage is more than 50%, we drop this particular column. It doesn't carry any meaningful information, so we drop this column. And here in this case, here in this particular case, there is missing value. What we can do here, we check which value is occurring more, or else we go for mean, median and mode and then impute the value. Imputing the value is nothing but replacing value with the most frequent value which is appearing in that particular column. Okay, so what is imputing missing value? Imputing missing values means replacing missing values with an estimates. Okay, replacing missing values with an estimate, then analyzing the full data set as if imputed values are the original ones. Okay, now if there are too many missing values in particular column, if missing value percentage is more than 50%, then we are dropping that column. And if you say missing value, this range is too much, okay, it depends on companies also. Not all companies take this as a threshold value. Many companies take missing value threshold value as 10%, 20%, especially in financial companies like JP Morgan, Wells Fargo, Citi, right? These companies, they set the missing values as 10%. Okay, 10%, because the data set, the financial data set is very critical. So they don't want to leave any variable. They want to maintain all the variables as much as possible. So here this threshold, setting a threshold depends on the companies. So here in this case, I am setting a threshold value of 50. And if a column has more than 50% missing value, then drop the column. Okay. Next, here I have taken the data set. I have pulled the data set. Train. This is the data set. This data set I have pulled from the GitHub. Okay. Now see what is happening here. Just try to understand the code. What is happening here? Here in today's class, not much mathematics is involved. Only mean, mode, median are involved. I think you all are familiar with mean, mode, median concepts. Here, I think you have already started working on import the required libraries, import pandas as PD, NumPy as NP, and this matplotlib is used for data visualization. And you pull this data set. This data set is existing in GitHub. Pull the data set, and it is available in CSV. If data set is available in XLS, you also know how to convert that XLS to CSV file. So now this is the data set. How to find whether the columns have missing values or not. So we use isNull_sum. It's a built-in function in Python. IsNull_sum. There are many functions. Not only this, isNull or not null, drop NA, fill NA, replace. So you can use these functions. Here I have used isNull, and here I am checking the percentage of missing values in each variable. So how do I check percentage of missing values? Here it is, I am training the model. I am just finding out which all columns have missing values in terms of percentage. It is returning the missing values in percentage. And when I run this code, I get this output. So what do you understand by this? What do you understand by this? This is the code. This is the data set. I'm not doing any complex calculation. I'm not doing any calculation. I'm just accessing this data set, and I'm checking the percentage of missing values in each variable and then displaying the data set. What you can make out from this data set, in this table, what you can make out is there are not so many variables having missing values. Only these two, item weight and outlet size. Only these two have missing values. Others do not have missing values. So here this function is null. It represents the variables which have missing values. So here what you can do for this missing values, we can impute the values using appropriate methods such as mean, mode, median, or we can set a threshold of say 10% or 30% instead of 50%, and then we'll try to remove the variables having more than 20% missing values. Now let us take a look at the code. And here what I'm doing, I'm calculating, and then what is being done here? Try to analyze this code. What is being done here?
Yes, literature survey is right.
I want you to apply your mind.
I thought they just started to maybe, so you can focus on that and then you see how you can implement it. Because I am
Here variables, the variables to be used are stored in a, what variables? Missing value variables. They are stored in a variable which contain only those features where the missing value is what to say, greater than or less than 20. What we are doing here? Try to understand this code. This particular variable is storing what values and this is storing what values?
Ma'am, we are only storing the variables which have less than 20% of missing values.
Correct, exactly, that's it. Here you are collecting the variables which have missing values less than 20%. If they are greater than 20%, we are dropping them, right? Okay. So any other answers? Any other observations here? Here, so the variables to be used are stored in a value called variable, which contains only those variables where the missing values are less than 20. Okay, correct. This is how missing value ratio is implemented in Python. The second one is low variance filter. So what did you learn in the first one? You are either dropping the columns which have missing values greater than 20 or imputing values using mean, mode, median. We'll see later in the further side how mean, mode, medians are used. Second one is low variance filter. What do you mean by low variance? What is the variance in statistics?
Ma'am, it basically tells the region, ma'am, what region is the data being spread.
See, okay, let us say if there is a column, particular column, say year, okay, there is a particular column year and all the column values are same values, 2021, 2021, 2021. Is the column showing high variance or low variance?
Low variance.
Correct, low variance. So what is low variance? What is a variance? Variance is a statistical measure of the amount of variation in the given variable. So we see if there is a lot of fluctuation in the values of a particular column, if a column values are different, if a column has values which show a lot of fluctuation, it means that particular column value is showing high variance. If the column values are same, it means that has very low variance. Now tell me, which one is going to impact the performance of the model? Is the high variance or low variance? Which one you are going to consider for the model building?
High variance, ma'am.
Correct. High variance. We need to consider a column which shows high variance. Correct. So here, if the variance is too low, it means it does not change much and we can ignore that particular column. We can ignore those values. And low variance filter. It's a dimensionality reduction algorithm. And what you can say, yeah. Let us consider a variable in the data set where all the values, where the observations, okay, where all the observation have the value 1. If we use that variable, if we use that column value, it is not going to improve the model performance. So we drop that. We call that particular column has a 0 variance or a low variance. So now in order to find out the variance, whether the column is exhibiting high variance or low variance, we need to calculate the variance of each variable in the data set, and then drop the variables which have low variance as compared to the other variables which are showing high variance in the data set. So why do we do this? The reason is that variables with low variance, they are not going to impact on the target target variable or outcome. So in this previous case, here item weight and outlet size will take the same variables. Yes, here these two have missing values, and these two, assume that these two have a low variance. First, we will impute for this, what do you see? Median, right? Here we impute the missing values in this particular column. It is a column, right? We'll impute the missing values in this particular column using median, and impute the missing values for this particular column using mode. I think you all remember what is mean and what is mode, right? What is mean? Mean is the, look at this example. Mean is the average number found by adding all the data points and dividing by the total number of points, right? For example, mean for this particular set 417. What is the mean for this set? 4 plus 1 plus 7 by 3, which gives us 4. That is the mean value. Next, how median is calculated? How median is calculated? Here we are calculating the middle value by ordering all the values in the set. Okay, first we'll take the order in the increasing order. We'll take all the numbers in the increasing order and then find the middle number, that is median. And if there are two numbers in the middle, for example, if there are 4 elements, we'll get 2 numbers in the middle. In that case, we take mean of those numbers and then find the median of the value. Now here, median of 417. What is the median of 417? First we have to take the order 1, 4, 7. Then find the mid value. Mid value will be 4. That is the median value. Next, mode. What is this mode? The most frequent number. Mode, it takes the most frequent number. Let us take the elements in this set 4, 2, 4, 3, 2, 2. What is the mode? 2. It means 2 is appearing many times, right? 2, because it occurs 3 times. 2 is occurring 3 times. So the mode value is 2. So now here median, here we are considering all the values of this particular column and taking the median of that and then placing the value. In the second one, out size, you can work on this data set during the lab session or whenever you are free, you take the same data set. I want all of you to take this data set, train CSV file, it is available in the GitHub, okay? And show me the results. I want to see the results. So next, what are we doing here? We are imputing the values using median for the first column, using mode for the second column, outlet size. Why are we taking only these two variables? Why are we taking only these two columns? These two columns are showing low variance. And next, what are we doing here? Here you have to check whether all the missing values have been filled or not. So what are you doing here? Train is null. What is this is null? Is null sum is used for checking the missing values and percentage of missing values. So now let us check whether all the column values have been filled or not. So now see, no column is giving any value. It means 0, 0 indicates they do not have any missing values. So now here this particular table shows that all the values have all the columns have no missing values. Now let us calculate the variance of all these values, all these numerical variables. So how do you calculate variance? Using the built-in function train var. So use this function and this is the output. When you run this code, you will get this output. So what can you make out from this output?
Item weight and item visibility is contributing less, so we can drop that column.
Item weight also, you want to drop item weight also?
Because it's low variance, no ma'am. It is one.
Yes. Yes, in this case, yeah, you are right. You are absolutely correct. And here there is an item, there is a variable called item visibility. It is -3, right? This is showing very low variance, right? It is showing very low variance. So there is no point in including this particular column. So it is better to drop this particular column. So let us see how this column is dropped in Python using low variance filter. Yes, what is being done here? You are in final year students. You have to make it out very fast. In the previous case, item visibility is showing very low variance, so it should be dropped off from the table.
Like both the students are entering.
Now, how are we going to drop this? I have already displayed the code. Just see what are we doing here. Are you able to understand the code? I said it works only for numerical variables. Low filter dimensionality reduction techniques only, it works only for numerical variables. It works only for numeric values. What are we trying to do here? What is this 10%? What is this range? What are we doing here?
Like similar to the last thing, we are including only if the variance is more than 10%.
Correct.
We are appending the variable.
Correct, absolutely right. Here, this code, what is this code good doing? It displays the list of variables that have a variance greater than 10, right? It is showing the list of variables that have variance greater than 10. And it is storing the variables here, appending the list. Okay, now I think you have class, right? One more class. Do you have a class now?
No, ma'am.
You don't have class?
The class was cancelled, ma'am.
Okay. Let me see. Okay, I will continue this in the next class with other techniques. Okay, thank you. Thank you, Priyanka.
Thank you, ma'am. Thank you, ma'am.
Ma'am, could you tell the mathematical concepts that we need to?
Yes. Thank you for reminding. Yeah, study Lagrange's multipliers, Lagrange's equation, covariance matrix. Okay, and one more, eigenvalue, eigenvectors. Okay, transpose matrix, you know, right? Covariance matrix, you know how to find covariance of the matrix. Please note down covariance of the matrix, eigenvalue, eigenvector, uh, Lagrange's multipliers. These are the prerequisites for the next class. All of you, please brush up these concepts. Thank you, everyone. Take care. Bye.
Thank you, ma'am.